Assalamualaikum and greetings everyone. Today's topic is on scalar and vector fields. Okay, let's look at scalar field. The definition of scalar field. A scalar field is collection of scalars assigned to each point in the domain of the field that satisfy a specific rule. So a scalar field z equals fxy in the xyz space is a surface, but on a xy plane it's a set of level curves. Okay, for example, so here we have scalar field is really collection of scalars that satisfy a certain rule. So for example, if you have y equals f of x, if you plot this on a xy plane, so for every x you have a value y, so you have collection of points. Okay, so collection of points will give you, so in this case the scalar would be points, so collection of scalars will give you a curve. Okay, but in xyz space, so let's say you have z as a function of x and y, so for every point xy in the domain you get a value z, so you have a point xyz and you have another point xyz. So if you collect all the points, you might have a surface. So scalar field is collection of scalars, or in other words, you're familiar with y as a function of x or z as a function of x and y. So in 2D you have a curve, in 3D you have a surface. So collection of points in 2D will give you a curve, collection of points in xyz space will give you a surface. Okay, so that is a collection of scalars, which is a scalar field. So here you have a collection of scalars assigned to each point in the domain of the field that satisfy a specific rule. So our specific rule would be a function of f here, and here we have a function of f as well. Okay, all right, so that is scalar field. For vector field, the definition of vector field is a vector field is a collection of vectors assigned to each point in the domain of the field that satisfy a specific rule or a formula. Okay, so on in an xy plane you have many points. So this is an example of scalar field. So this is a vector field, which is really a collection of vectors. You can see that here for every point you have a vector. So every point here, point xy, you have a vector. Here we have a point xy, you have a vector. So collection of vectors at each point xy. So here we have point xy. So at every point you have a vector that is the vector satisfy a certain rule. So here for the x component it has to satisfy this rule, for the y component it has to satisfy that rule. So from there you get so for each point you have vectors. The collection of vectors is called vector field. Okay, collection of vectors is called a vector field. So same thing for in xyz space, you have collection of vectors as well, but then it has to be in xyz space. So for every point xyz you get a vector. Okay, so a collection of those vectors is called vector field. Okay, so collection of scalars is called scalar field. You're familiar with function, so that is another fancy name for function. It's called scalar field. So collection of vectors is called vector field. So here I'm just give you one example of a vector field on a xy plane. The same thing in xyz space, you would have collection of vectors, so that is called vector field. Okay, now we're going to concentrate on scalar field. Okay, for scalar field, let's say you're given a scalar field. So here you're familiar with this is previously you just called this function a function in terms of x, y, and z. Okay, so let's say you're given a scalar field or a function. There are two partial derivatives that involves this scalar field. Okay, so if you use partial derivative on the scalar field, we have two items that we need to study here. The first is called gradient of scalar field, and the second is directional derivative of the scalar field. Okay, we're going to look at both. How are we doing with time? We good? Okay. All right, I think I'm going to save operations on scalar field that involves partial derivative in our next video. Thank you.